Here we have an example probability problem that reads like this. To assure product quality, a company checks a random 4 items they produce at the end of the day. They produce 10 items on a given day. If 3 of the items were defective, what is the probability that a defective item is detected? Okay, first off, in any probability problem, you're going to want to determine, you think about an outcome of the experiment. Okay, what's an outcome of this experiment? Okay, our experiment is to select 4 items from 10. Later we have to determine the probability that we draw a defective item, and we are told that there's 3 defective items, but our outcome is going to be a selection of 4 items. Okay, so a possible outcome is, say I pick 4 items, let's say one of them is defective and 3 are not defective. Okay, another outcome would be 0 are defective and 4 are not defective. Okay, and so on. You know, I could get all 3 of my 3 defective items and then get 1 non-defective item. So those are outcomes, and that's going to help you think about how to set up the problem. Okay, so let's go back and we will draw our probability here. That was really slanted, but anyway, okay, so in this item we're concerned about the number of defective items and the number of ways to pick a defective item. So that's going to be our top part. And then the bottom part is going to be all the elements in the sample space, the number of elements in the sample space. Well, we know that we're picking 4 items, and we know that there are 10 items produced on a given day. So we know that we're choosing 4 of the 10 items. So number of ways to choose 4 from 10. That's kind of sloppy. Okay. So next, if you haven't figured it out by now, well, let's think about this problem. Do you think it's a permutation, combination, or neither? Well, you know that permutations, order matters. So if we look at the problem, there's nothing about this problem that tells you order matters. You could pick 3 defective items in any particular order. You could pick defective item number 1, defective item number 2, then defective item number 3, or the other way around, and it would still be the same thing. 3 defective items. Doesn't matter what order you pick them in. So order doesn't matter. And so, but we do know that we're picking 4 items from 10 at random, and that's going to give you a pretty big clue that this is a combination problem. We're going to be using combinations to solve this problem. So the next thing we need to do is decide how we're going to represent the number of ways to pick a defective item. And to do that, we can go back and think about our outcomes again. I was saying we could have picked 1 defective item and 3 non-defective items. So let's just write that down here. And I'm going to go over a little farther. So I've got my 3 defective items because the problem tells us there's a total of 3 defective items. And I'm choosing 1 of them. Okay, and then which means multiply, then I'm going to be choosing, and since I have to pick 4 items, that's the experiment. I can't just pick 1 defective item and stop. I have to continue on and then pick 3 more items, and I can't pick from the 3 defective ones. So what does that leave? That leaves the 7 other items that are not defective. So I'll be choosing 3 from 7, because you know we have a total of 10. 3 are defective. That leaves 7 good ones, and we've picked 1. But we have to pick 4, so that leaves 3 to go. And this is all one experiment right here, and this is basically step 1, then step 2, and represents multiplication. Choosing 1 and then choosing 3 more. Okay, but we can't just stop here and take this all over 10 choose 4. And the reason we can't do that is because, well, this is representing only one way to pick a defective item. we need to find all the ways that we can pick a defective item. Okay, so we can pick one defective item, or we can pick two defective items. And again, even though we've picked two, we still have 7 left to choose from that are good. We're going to be choosing from the 7 ones that are not defective, and since we have picked 2 this time, there's only 2 left that we need to pick, because that will total 4. And again, there's still, you probably figured out, there's one more way to do this. We can pick all 3 of the defective items that we have, and then we could still have to pick one of our good items. So keep in mind, OR means add, so you know that all of these are going to be added together. And the reason that you're going to be adding them together is because these are all separate experiments. That's the way you need to think about these. These are all different experiments. I'm not picking one of the 3 defective, then 3 of the 7 good ones, and then going back and picking 2. You know, I would have to replace them in order to do that, and if I were to do that, I would have to. It's a whole new experiment. Okay, so when we're starting a whole new experiment, we're just going to be adding the number of ways together. Okay, so go ahead and draw this line, and down here we're going to get the number of ways to pick a defective item. Okay, and I'm not going to go through and explain how to solve these probabilities, because you should know how to do that by now, and if you don't, you can always go back and watch the videos on that. And actually, we're going to dedicate either a video or a series of videos on just quick shortcuts to solving combination problems and permutation problems to speed you up in problems. And we're probably going to do reducing fractions and stuff like that, in case you're rusty on that stuff from high school, because those little things, with as complicated as some of these problems can get, and as long as some of them can get, if you're rusty on your algebra and you're reducing fractions, and you're not quick enough with your combinations and permutations, it's really going to slow you down on the test, even if you know how to do the problems. And you're not going to do nearly as well as what you could. You're just going to be using a lot of extra time doing operations, and you're going to be more likely to make a mistake and do a problem right but still get the wrong answer. It's really easy to do in this class. So I recommend you go back and refresh on those things. Just a half hour on it will help you out a lot more than what you think. Okay, anyway, we know that 3 choose 1 times 7 choose 3 is 105. 3 choose 2 times 7 choose 2 is 63. And 3 choose 3 times 7 choose 1 is just going to be 7, and that's going to give us a total of 175 ways. And that's the number of ways to pick a defective item. That's 175. And we know that must be true because there's only 3 defective items to pick from, so we can't pick more than that. So we can only pick 1, 2, or 3, and if we pick 0, well, that's just not going to add to the number of ways to pick a defective item, and that's what we're looking for. So we can go back up here and plug that into the top, and the bottom you can probably figure out just by reading it. We know that it's representing the number of elements in the sample space, and well, that's the number of ways we can pick 4 items from 10, so that'll be C of 10 4, and that is going to equal 210. So this will reduce down to 5/6, and that is the probability that a defective item is detected, and that's the answer to your problem.